Welcome to today's presentation. My name is Faiz and I'm the Network Support Engineer of the F5 Networks. We will be presenting the high-level overview of what BIP DNS or GTM has to offer. Throughout the sessions, we will be discussing on the function and the supported features of BIP DNS. But before we go on to understanding the features, we'll be discussing on how DNS works in general in our daily day-to-day usage. We will also go into the troubleshooting session in the later presentation. Without further ado, let's start. DNS, known as Domain Name System, is a protocol that uses UDP or TCP on port 53. The purpose is to translate a fully qualified domain name, FQDN, to an IP address. The main objective is simply because human mind find it difficult to remember all the IP addresses that are in the world, and what happens if the IP addresses changes over time. This is where DNS comes in handy. In order to understand DNS, we will need to go and take a look at the hierarchical of DNS. Giving an example of a client trying to resolve www.f5.com on the browser search bar, what you do not see at the end of .com, there is a dot that is referring to a root server. Root server is an authoritative name server that serves DNS root zone. An operator such as Big IP usually manage the resolver must have it configured on the system. So Big IP usually managing the DNS recursive resolver would have the root hints file that contains the IP addresses that you see on the table on the left side. There are 13 root servers around the world, and it contains the database of the TLD. TLD is the top level domain, which can be explained on the next slide. TLD is maintained by IANA, Internet Assigned Number Authority, and it contains the root zone database, and some of the examples can be found on the table on the right side. The one that you are familiar with, probably .com, .net, .org, and some of the examples as follows. Next, we will take a look at the types of DNS queries, how the DNS queries and response works, and what's the differences between recursive and iterative DNS query, which can be explained on the next slide. Recursive is a process where a server will completely answer the request or return an error, whereas iterative, the non-recursive process of a server that responds with a complete answer if it already has the cache before, or it sends a referral, or it sends an error back to the client. So let's focus on the picture on the left. Client here referring to a browser. When you try to do a query to, for example, www.f5.com, what it does at the background is that it will send recursive query to LDNS server. The server one here is referring to local DNS that usually you would get it from the DHCP assignment, or you can specifically assign or configure it on your desktop. So this process here is called recursive query. And the LDNS is responsible in doing the iterative query, meaning that it will try to find the answer for you, and it will go down the hierarchical structure, meaning that it will send the query to a root server, and the root server will send a referral back to the LDNS to go to the top level domain, and the top level domain will actually send referral back to the name server, depending on what FQDN you are trying to query. Next, we will move into a client's configuration of DNS, for example, Linux and the Windows client. On the Linux, There are three files that located under /etc directory. One is nsswitch.conf, second is /etc.host, third is /etc/resolve.conf. So the first nsswitch.conf is nothing but giving you the condition that it will look to the /etc host file first to resolve the name, and then it will look into the /etc/resolve.conf to resolve the host name. And /etc/host is similarly to what you found on the Windows c/window/system32/drivers/etc/host, where you can actually edit the FQDN statically and assign the IP address to it. And thirdly is the resolve.conf, where it involves the resolving process, trying to determine the local domain name. On the web UI interface, you can actually configure the DNS servers through the network manager on the Linux machine. And from the Windows machine, you can do it under the IPv4 properties. Under CMD, you can view your configuration of DNS server through the ipconfig/display DNS. Okay, when we talk about system that managing the DNS zones, so it must have a zone file in the format that being adopted by Bind. Bind is nothing but a software that does the resolving or receiving response and replying with receiving requests and responding with the DNS query. So if you look at the example on the far right, on the upper right corner, you would see the zone file for example.com. This is where you see the origin statement being stated. And it does contain the information such as the SOA with the respective SOA and the serial number, the TTL of that particular zone, DNS record, MX, CNAME, and so on. So this is usually stored under the directory, named directory of a system, for example, the IP DNS. Giving an example that if you try to query fred.example.com, you will get an answer 192.168.0.4. And for example, if you go www, you will get an IP address of 192.168.0.2. However, there are configurations such as CNAME, which is an alias to the ftp.example.com, and it alias to www.example.com. For example, for a client, you're trying to access ftp.example.com, it will give you a CNAME record of www.example.com, where www return the IP address of 192.168.0.2, which is the error code for www. Okay. So on the bottom, you would see the reverse mapping zone file. This is not mandatory, but it is needed, for example, if you were to set up a mailing agent. So it has the format of in address ARPA, and the IP address is reverse, basically 192.168.0, and the respective number 1, 2, 3, and 4 for the respective FQDN. So this is just a pointer record for that particular reverse zone. Okay. Next, there is a features on the DNS server that called DNS zone transfer. DNS zone transfer is a mechanism to transfer or synchronize DNS database across multiple DNS servers. DNS master server, which is typically the primary server, will share the zone file or the records among all the listener, or the one that being allowed to send the notify and transfer from the DNS master server, which we usually call it as a secondary DNS server or a slave. The communication between the servers is through port 53 and protocol TCP. So how it works is that the master server will basically send AXFR or IXFR to a DNS slave server. So AXFR is basically the whole zone file information being transferred to DNS server, whereas IXFR is the incremental transfer where it can look through the serial number of the zone file, where if there is any update of the zone, it will not send the whole table to the DNS slave. It will send the incremental, whatever changes that has been made on the master servers. So the master server configuration can be found under named.conf in this format. Zoneexample.com, the type is either master or slave. This is basically the example of a slave DNS server where the master DNS server IP address is 192.168.23.17. And below is the example of a master server where it allows the notify of the secondary server, which the IP address 10.0.1.2. So the two parameter that needs to be pay attention to is allow notify and allow transfer. So transfer is basically AXFR or IXFR. Notify is the process of sending the updated or the IXFR to the DNS slave server. Next, we will look at the packets of a DNS query and response. How does it look like on the Wireshark? So, as you know, this is an example of a UDP packet where it has the DNS header, the question and answer section, the authoritative section, and the additional section. The IP header, UDP header is basically as normal as how you would see on the TCP as well, but we should be focusing on the DNS payload as a whole. You can see that the flags has response, opcode, and if the message is truncated or not, and so on. We will not go into the detail of this, but what you can see is that when a query, meaning a client trying to query a specific IP, specific FQDN, such as this is towards www.google.com. This is part of a question. If you look at the question, the bit set to 1, where the answer set to 0. By this, we would know that this message is a query and is written here under the response flag. And on the right side is the this basically is a response. If you look at the response flag, this message is a response. The differences is that this bit is set to 1. And if you look at the answer, you would see there are 6 IP addresses that being returned to the client. For example, www.google.com, a record of it is 172.217.194.106, 172.217.194.104, and so on. We will look into it in a bit. So we will move to the next session, which is DNS application. This is where I want to show you how we can troubleshoot using DNS and how do you do a query to DNS. Okay, as you all know, if you are using Windows, there is an application called NS Lookup. So if you look here, 192.168.213.180, that is the local DNS that I've gotten from my DHCP server. So if I type in www.google.com, I will get an answer. Okay. Similarly, if you do a packet capture on your Wi-Fi or Ethernet interface, you will see the same thing. So filtering on DNS, do NS lookup to www.google.com, you will see that it goes through the process to the local DNS server and returning you the A record or A or quad A records and so on, if there is any. So this is NS lookup, and you can also change the LDNS to a local public server such as 8.8.8.8. How do you do that? You just type in server 8.8.8.8. Now you are actually pointing to the Google public DNS and you're trying to resolve www.f5.com. Let's take a look on how it looks like on the capture. So you can see the query of f5.com would actually return a lot of answers. There are 5 of that, where you can see it on the NS lookup answer as well. So including the CNAME and the 4 A records. So I mentioned earlier about the zone transfer. You can also do a test using NS lookup on zone transfer. For example, you can do set type equals to any, and then ls -d www.f5.com. This is where you are trying to do a zone transfer from your client to the 8.8.8.8, trying to obtain the f5.com zone file, which is obviously not going to work, but this is just for example purpose. I'm just going to show you that if you run this, you will see it is communicating through TCP. So if you look at this is the query AXFR trying to get the f5.com zone file, and the protocol that it uses is TCP. Second application that I want to show you is by using DIG. DIG is basically a software that you can install on your Windows machine or from a Linux machine. It usually comes together with Bind, or Mac OS usually comes together on the terminal. So you can do a DIG directly to the server, for example, www.google.com. You will get an answer of the A record for the Google. So these are all the IP addresses for the Google. If you want to run against your local DNS, you can just omit the IP address. You get the IP address of the Google. So if you do a trace, this is useful when troubleshooting where does it start or where does it not work when you try to query through the ladder. So if you look here, if you try to do a trace on www.google, you will go to the root server. The one that is answering you is the M root server, the 202.12.27.33. will give you the referral of the NS name server of the Google. There are 4 of them, and it chooses one of it. And you can see that the ns1.google.com, which the domain server for the Google, return and give the answer to your client of the 6 IP address. Similarly, you can actually query for a specific record. For example, let's say gmail.com MX record, you will get the Gmail record for the MX record for that gmail.com, and so on. You can do research on this, on how to, and the commands that are available for dig and NS lookup. And this is all for now. Thank you, and we will see you soon on the next session.